Alright, last thing. This is a special case. I wouldn't necessarily call it a collision, but it is an interaction between two objects that we can use momentum to analyze. Take a look. You got a cannon here, and what ends up happening with cannon, if you ever notice, cannons are always on wheels, because when they fire, what they end up doing is that they roll back. And you never want to be behind it while it's rolling back, so you want to avoid the recoil. Anything that ends up being fired will end up recoiling. So if you fired a rifle, the rifle will recoil on it. If you fire a Nerf gun, the Nerf gun will actually recoil on you as well. And then the last thing you see is you see explosions as well. Now, we've kind of done interactions like this. If you think back to the two Pasco carts, what I did was we had cart 1, cart 2. They're both at 0 meters per second, and then I tapped spring launcher on one of them, and then they go flying off opposite ways here. It's the same idea for the recoil. And you know, we'll actually do a calculation here. If you look at our clown, he's getting fired out of a cannon. The cannon's 500 kilograms, the clown is 100 kilograms. And he's getting fired at a speed of, I can't read that through my screen, 15 meters per second. So we want to calculate the speed of the cannon itself. So we'll do an example problem here as well. So here's our cannon here, and it fired a person out. And that person's moving at 15 meters per second. We have their masses. The person's 100 kilograms. The cannon here is 500 kilograms. Now you got to think about it. Initially, the cannon and the person is inside the cannon waiting to be fired. So they're both at 0 meters per second. So if you did the momentum before, nobody's moving, so it's 0. The kinetic energy, it's 0 as well. All right, there's nothing. After, that's a different story. He's moving that way, he's moving that way. But what ends up happening here is that the momentum still has to be conserved in this interaction between two objects here. So if you think back to the formula for collisions, the golden formula was this. It was m1 v1i plus m2 v2i. There's your initial velocities. m1 v1f, m2 v2f. There's your final velocities. The whole left side of this is 0, 0. The total momentum is 0. The final momentum must also be 0 then. But we look and we see our clown here, he's got some velocity to him. So our cannon, we don't know what that velocity is. Let's call it V1F. But the clown here, his mass is 100. It's moving at 15. We can do this math. We can solve this. All right, one unknown here. So 100 times 15 is going to give us 1500. So that's 1500. We'll move it over to the other side. It's now negative. Last step, divide both sides by 500. And what you're going to get is that V1F equals negative 3 meters per second. It gives us the direction, and if you then plug this in and find out the momentum of this object here, it's going to offset the momentum of this object here. So you might want to make note that the total momentum after is 0 as well. Now we said that the initial kinetic energy is 0, but we said kinetic energy is always positive. Looking at these two things, both of them have kinetic energy. So let's take a look at the kinetic energy here. It would be 1/2 times 100. And this is the clown, he's moving at 15. Square it. You got the cannon as well, 1/2 times 500. Moving at negative 3. Square that. They'll both be positive here. So you got 1/2 times 100 times 15 squared plus 1/2 times 500 times negative 3 squared. Here's what we get. We go from 0 joules of kinetic energy to 13,500 joules of kinetic energy. In your recoil, you want to make note here. Momentum is conserved. Momentum is conserved for any interaction between two objects. But what ends up happening is kinetic energy is gained. And it's got to be gained from somewhere. Where it's gained from is from some sort of potential energy, usually. Think about when I have the two cards here and I activate them, I'm hitting a spring, it's releasing potential energy. We're converting that to kinetic. If you're thinking about the clown here, there's some sort of explosion. That would be some sort of chemical potential energy, which, we're not all that much concerned with how that works in this class. But there's always some sort of stored energy that's being utilized in these interactions, so it doesn't just come out of thin air. All right, so that's how a recoil interaction works.